Line coding. The binary data cannot be transmitted directly, but instead they should be converted into electrical waveforms. The form of the process of converting binary data into electrical waveforms is called as line coding. The following are some of the different forms of line coding: unipolar non-return to zero signaling, unipolar return to zero signaling, polar NRZ signaling, polar RZ signaling, bipolar NRZ signaling, bipolar RZ signaling, Manchester signaling. First, we will take the unipolar non-return to zero signaling. In this line code, symbol 1 is represented by an amplitude plus A for the symbol duration, and symbol 0 is represented by switching of the pulse, or it is a 0 volts. So, for example, the binary data is 1, 0, 1. 1 is plus A, 0 is 0 amplitudes, or it is simply switched off. Again, 1 is plus A. In mathematical form, the expression for this is x of t is equal to plus A for a duration of 0 to TB for symbol 1, 0 for symbol 0. And this is the power spectra of this coding, unipolar NRZ coding. So here the power spectral density, it is the plot of power with respect to frequency. So when we observe here, it starts from 0, 1, 2, it is a normalized frequency, and y-axis is a magnitude of the power. And we observe that at 0 frequency, it has a DC component. Disadvantage of this type of signaling are the waste of power due to the transmitted of a DC level, and the power spectrum that transmitted signal does not approach to 0. Okay, again, okay, it will be fluctuating here. Unipolar return to zero signaling. In this line code, 1 is represented by a rectangular pulse of amplitude A for a half symbol duration, and 0 for remaining half symbol duration. Symbol 0 is represented by transmitting a no pulse. That is, for symbol 1, x of t is equal to plus A for a 0 to t by 2 and 0 for a remaining half of the duration. For symbol 0, it is simply switched off on 0. 1, 0, 1, 1, half of the duration plus A, 0, it is a 0, 0, entire duration, it is a 0 again. And the power, this is the plot of the, again, power spectra. It's a disadvantage is that it requires a 3 dB more power than polar return to 0 signaling for the same probability of symbol error. Polar NRZ signaling. In this scheme, symbol 1 and 0 are represented by transmitting a pulses of with an amplitude of plus A and minus A respectively. That is, x of t is equal to plus A for 0 to TB for symbol 1 and minus A for a duration of 0 to TB for symbol 0. 1 plus A for an entire duration, 0, it is a minus A. And this is the plot of the power spectra. The polar NRZ line is relatively easy to generate, but the disadvantage is that the power spectrum of the signal is large near 0 frequency. Okay, again, it will has a this is a waste of the power. Polar RZ signaling. In this second line of code, symbol 1 is represented by plus A for half of the duration and 0 for a remaining half of the duration. Symbol 0 is represented minus A for half of the duration and 0 for a remaining half of the duration. That is, x of t is equal to plus A for half of the duration, 0 for a remaining half of the duration. For symbol 0, minus A for half of the duration and 0 for a remaining half of the duration. So consider 1. For half of the duration plus A and remaining it is a 0. 0 minus A and remaining half of the duration it is 0. Bipolar NRZ signaling. In this line code, plus A amplitude used for alternatively for symbol 1 and no pulse is always used for symbol 0. This method is also called as alternate mark inversion. Consider now 1, 0, 1, 1. 1 we have a plus a, 0, nothing is transmitted here. Next it is a 1. So here we have a plus a, now it is a minus a. It is now minus a, again we are going to change, okay. It is a plus a. Bipolar RZ signaling. This line code uses a 3 amplitude levels. So plus a and minus a. For symbol, okay, half of the symbol duration. Again, you will look at that half of the duration, it is a plus a, remaining it is a 0. And again, for 1, minus a and 0. When it comes to the 0, nothing is transmitted. And this is the power spectral density of the bipolar RZ signaling. Manchester signaling. In this method, for symbol 0, the polarity, so polarities of the pulses are reversed here. Okay, look at this. Plus, to transmit a 1, symbol 1 is represented by a positive pulse of amplitude A, followed by a negative pulse of amplitude A, that is plus a minus a, starts from plus and minus. Similarly for 0, it is an inversion of that. So that is a 0 minus a to plus a. Again 1 plus a to minus a. This is the power spectra. The power spectra of and again a unique property of the Manchester code is that it suppresses the DC component. We don't have any DC component and has relatively insignificant low frequency component. We don't have any side harmonics here. This property is essential for some of the applications.